Hey guys, today we are going to solve minimum absolute difference between elements with constraint problem. So we have given an integer array enums and an integer x. Find the we have to find minimum absolute difference between two elements in array that are at least x indices apart. In other words, find the two indices I and j such that absolute difference between the indices is greater than equal to x and absolute difference between the numbers is minimized. Return an integer denoting the minimum absolute difference between two elements that are at least x indices apart. So taking the example first, we have num array 4, 3, 2, 4, x is 2. So two distances apart we have to check. So here 4 and 2 is two indices apart. So 4 and 2. So difference is 2. Nums difference is 2. 4 and 4 0. 3 and 2 sorry 3 and 4 1. So minimum value is 0 possible. Okay. Taking the second example, we have 5, 3, 2, 5, 10, 15, and x is 1. So one indices apart. Here 5 and 3 are one indices apart. Then 5, 2, 5, 10, 5, 15. Similarly, 3, same goes with 3, then 2, then 10. So we will find 3 and 2 is giving the minimum possible answer 1. So what are the constraints here? We have constraint nums array length 10 to the power of 5. So obviously if we are going with the brute force solution, that is n square, where we are picking each element and remaining second element from I plus x indices. So that will be the n square, but n square will not work because constraint is 10 to the power 5. So what will be another approach? So another approach can be possible. We have when we are at ith position, then we have to check I plus xth position to till end, whatever values are, that is in sorted order, and the ith element we will check the nearest closest number to that ith index number 1. So for example, if we have 4, then obviously from here onwards we have array 2, 4. So we have to find 4 closest. So 4 closest, if greater than equal to we are checking, then it is 4. So it is giving the answer. Similarly, same goes with the 3. If for 3 we have only 4, so obviously the closest one is the 4. So we can minimize. So but we have to find a better way o of log n, that thing, to so that our approach will be n log n, and n log n will work here. So let's start with what is the data structure we can use here to serve those purpose. We have tree set serve will serve that purpose, and here we will take tree set integer, tree set new tree set. Now because tree set can't handle the duplicate ones, so we will keep one hash map for keeping the count. So here we are taking map integer num count. So we are keeping this hash map. Now first, what we will do, because we are going to iterate from left to right, so initially we will keep all the elements in tree set and num count, and whenever we are visiting then ith till ith plus x minus 1 index, we will remove those elements. So initially we will keep all elements. So let's try to iterate all elements here. So let's increase the num count also. Get dot default value as 0. Okay. Now what we are going to do, we will keep one index j, and one is then we are going to iterate for loop int I equal to 0, I less than nums dot size. Now we will take the current element. So before that, we will remove all the elements till I plus x minus 1. So for that, we have kept j. So j should be less than I plus x, and j should be less than nums dot size. And what we will do, and we will increase j, but before that, we have to remove the elements also. So to remove the element, first we will decrease the, we will take here. So we will keep one num variable here, and in num variable we will keep current element. So nums dot get jth index element, and then we will decrease the count. Mm, num So we will get num count dot get the I, so num and minus 1. And if count is 0, count dot get num. If count is 0, then we will remove from hash set, because no longer this is going to give any. So we will remove that to avoid any invalid cases. Now here we will have to remove from t set. T set we are removing. Now once we will reach there, we will take the current element. Here the current element nums dot get ith element, and after that this is the current element we will take. So tree set have properties ceiling and floor, that will help because that will be the closest numbers. So we will going to take that one seal. So tree set dot ceiling. Okay, here ceiling we are going to take num. Obviously, if there is no number, it will be null value. Similarly for floor, now we will check. If it is not null, then we have to do operation. If it is not null, then we have to take the minimum. So answer, we will initially take this variable min answer, and integer dot max value, and here we will take min answer as this one, math dot min answer, and math dot absolute value, this seal value minus num value. Okay, similarly we are going to do for floor. Now we are going to return min answer. This will be our answer. So what we have done, we took the set because it holds the property to find out closest element by ceiling and floor function, and we kept num count to keep the count because it doesn't allow duplicates. Reset doesn't allow duplicates here, so that's why we are putting the count also. And initially we inserted all the elements, and then we took the maximum value as the initial value. Then we kept j just for removing the all element till I plus x minus 1. And whenever we are going to the ith element, we are first removing till I plus x minus 1, then we are taking the current number. Then in reset we are checking for closest one, and we are finding the minimum possible answer with this constraint. Now let's try to run this one. So okay, accept is accepted. Sample test cases are accepted. Let's try to submit. Okay, it ran successfully. Thanks.